in the context of sharing knowledge, we will open, let's say, the deepest of our hearts to offer you visibility on how all these initiatives that our colleagues mentioned yesterday are supported in EUIPO. This is basically where we base now our blockchain proof of concept, our AI platform, and everything is running on this infrastructure. I will take you through a journey from the beginning, how we decided to go here, and what technologies we are using. As every cloud-native story, it starts with a monolith. You all know possibly this one. And yes, our old systems were that imposing to developers. So we had usual J2E architecture, usually for all systems, with the user interfaces, all the components inside particular system with the integration layers, and sometimes we were also sharing business domains in the same system. So, for example, we had an application server, we had a system for managing trademarks and oppositions, other system for designs, recordals, workflows, payments, everything was running on the same server. High availability was a challenge, so we were just duplicating the same machines. These were all running in virtual machines at the moment, and some maybe in bare metal. Sorry. So most applications were active-passive. They were not managing well the sessions. So if we had to restore from, let's say, from an outage, we would have to activate the second instance of the system manually. They were integrating through databases, they were sharing resources like memory and CPU, and there were no self-healing capabilities. So if you had a damage, then you had to manually do an intervention, usually to restore the service. What was worse was that we had also cascading failures. So sharing the resources, we could easily go to something like this. And then we had huge problems. So let's say that the systems went quite large. Our flagship system, before it was decommissioned, it was, I think, 500,000 lines of code, out of which 60,000 were in JSP. Just imagine. They were hard to understand for new developers because of the sheer size. They were complex, and they were using non-standard ways in order to deploy and to configure. So for every single system, there was a new learning curve in order to understand how it worked. We had reliability issues due to the increased blast radius. A damage could affect many systems together, and they were difficult to scale, so teams were hard to organize. Also, they could not be extended as easy or to allow us to introduce new technologies. So around 2015, during our previous strategic plan, we decided to move to a microservices architecture in order to explore this agility that it was promised. So we started applying domain-driven design to organize the systems and the teams into groups around business functionalities or different functional areas. We leveraged API-driven development to be able to decouple systems, and the idea was to produce a back-office system with a harmonized user experience from the user perspective, but underneath to have a multitude of different independent and decoupled microservices. So the architecture looked like this. Since people were wondering actually about technical stacks, we were using React.js for the front end, Spring Boot for the microservices, and we used Consul and Joule for discovery and routing internally to the cluster. So teams were able to handle specific microservices like the red and the yellow over there. These, imagine that could be a set of services managing a domain like trademark or a design or let's say management of workflows. The problem though was still that what would you do if you wanted to scale a particular service? the way that we were deploying, we had to duplicate the whole server. This actually meant that the deployment was still imperative. It was bound to the particular server. The orchestration was quite complex. We were using Puppet at the time, and scalability meant that we had to duplicate the servers, which meant also a waste of resources, because imagine that maybe not all the deployments on the server had to be scaled the same way. So around 2017, we decided to explore a possibility of adding an orchestration platform and move to containerization. And after quite some research, our teams decided to go with Kubernetes and Jenkins for managing the deployments. So basically our technical stack was based on Docker to containerize the applications, and then use Kubernetes with Ansible to deploy the infrastructure, and Jenkins to manage the build pipelines. So Kubernetes or similar orchestration platforms like let's say Docker Swarm or Red Hat OpenShift basically are deployed on particular virtual machines or bare metal servers. They have a technical stack that provide all the functionality, and then you are able basically to deploy your different applications that we depict here with these images. So we had a container runtime, which was Docker, orchestration platform, Kubernetes. We kept Spring Boot as the microservices framework, and we used Spring Cloud Config for configuration management. We try to move configuration outside of the applications so that it can be distributed and have the same high availability benefits that Kubernetes was guaranteeing. So how a user accesses this application? So you have a load balancer in front. So when the user requests a resource, then from the service registration, the request is directed to the particular service. Let's say here is the green. So next, a benefit of the platform is the resiliency that we didn't have before. So what happens when an application fails? Kubernetes detects it, this is done in the platform, and then it's moved to a different server. And this is done automatically by the platform. If you lose a node, let's say again the cluster will identify it and will move all the deployments to the rest of the virtual machines. Another benefit that we take advantage, and this is actually what our colleagues from IP Australia mentioned before, is transparency and zero interruption in the service. And this is done using rolling updates. So when you deliver or when you deploy a new version of your application, basically the system deploys the new version, which you can see as the green one in this slide, and then it gradually moves, changes, let's say, the version of all the deployments of each component until you finally have the new version deployed. And with this, you guarantee that your users do not see any service interruption. So having all this, we moved to a decision saying, okay, now we have a platform that we can trust and we have some knowledge. So let's try to replace our current disaster recovery solution, which was based on, I think it was a data center in London, no, Raymond? Yes. So we said, okay, let's move it to Amazon. So what we did is that we took our infrastructure in Kubernetes that was already deployed in Ansible, and we used Terraform also to describe, let's say, the infrastructure in Amazon AWS as code. We Dockerized some standalone versions of our e-filing systems in order to be able to be deployed in the new infrastructure, and we used infrastructure as a service and platform as a service in Amazon in order to deploy the new version, which was actually mirrored from our on-premise environment. And this is about a very, very high-level diagram of the architecture of the workflow. So an administrator, at the moment that the DR is activated, is using Terraform and Ansible to provision a cluster and Kubernetes cluster, and also trigger the deployment of the e-filings. Here I have, for example, trademark e-filing and RCD filing. And it also provisions a database. So The infrastructure provisioning, it's not 5 minutes, as you mentioned before, IP Australia. It was about 20 minutes for us for deploying the infrastructure. This, of course, is different because when you start from zero, you need also to provision the virtual machines and all the necessary infrastructure. If I imagine that in other approaches, when you have a shared data center with a cloud, you can directly focus your traffic to the cloud, so this becomes really, really faster. So with all this, more or less, we had from zero a clean e-filing deployment in about 30 minutes. And this was, I think, it was achieved this month, I think, in the DR exercise that we did. So we moved from microservices, we moved to Kubernetes for orchestration, and we had achieved also a cloud deployment. So we had portable solutions that could be deployed locally as well as in the cloud, and we managed to achieve a lead time to production in less than 1 day for the applications that were actually included in the platform. In some cases, we could also do changes during business hours because there was no service disruption, and this is a key enabler to agility, really. And we had higher availability and self-healing applications. So next goals were to establish a common understanding between development and operations teams, because everyone needs to be on the same page regarding the platform. We wanted to have faster feedback loops from the users. When we were receiving, let's say, during a testing period, feedback about the application, we wanted to be able to do the development and start deploying already in the same day, so that the next day the users could actually test the new features. And we wanted the developers also to be able to deliver and deploy either to QA or, well, not really in production, but at least in QA environments. And this also was enabled with, we wanted to enable this with test automation in order to move quite some approval tests in the platform. So we decided to establish or to adopt a practice called GitOps, a new operating model that was coined from a company called Weaveworks in 2017. And this is basically democratizing the infrastructure. So everyone has an opinion on how it works. What this achieves is a declarative approach to deployment. So you are able to have your infrastructure defined in source code, in Git. This could be done by developers, and then it can be applied by anyone in any environment. You have increased security because this model decouples completely your integration, your continuous integration platform from operating the target cluster itself. You have auditability because everything is in Git, so you have to do pull requests. You can see the commit log in order to see what was changed and by whom. And you have improved stability because every environment is following the same configuration, along with consistency and standardization, because using these standard methods, let's say, everyone in the industry knows how your infrastructure is being deployed. The tool that we used was Argo CD. It's this little guy over there. So this is how our continuous integration and continuous deployment pipeline looks now. So it all starts from the developer who commits the code. The process, the build process starts, it publishes it runs the tests, it publishes the image into the image repository, and then the developer or any operator, anyone that needs to deploy, changes just the version of the application in Git, or if it is a new application, it defines the new deployment, let's say, manifest, or the code in order to deploy to the infrastructure. When this is done, the change is detected from Git by the platform, and the image is pulled from the Docker registry. So how we organize our clusters? We have 4 Kubernetes clusters. We have a non-production cluster where we have the QA and development environments. We do think that this should be split, so we will probably split this environment further. We have the production environment, which where we run our production workloads, with a data science cluster as well, which is basically the environment where our data science colleagues here, David, as a representative, is his little toy. The data science cluster has specific infrastructure, so we have servers with faster disks, servers with GPUs, and we can, using Kubernetes, we can actually target specific workloads to run on these servers for faster processing. And we also have deployed some tooling that is used by data scientists. Then we have our continuous CI/CD cluster, which runs all the tooling like Jenkins, Selenium, which is the automatic test platform, and our Docker registry. All of these have an Argo CD daemon that actually monitors always Git for the cluster state, and when different is identified for the deployments that are configured to be synchronized automatically, it just synchronizes the state, the desired state, into the cluster. So some numbers: we have 4 clusters. We have 263 deployments in the production cluster. These are different microservices, and these are offering actually production services. And in total, we have 1,174 deployments across all clusters. These run stateless microservices and stateful applications. We are running Kafka, we are running Elasticsearch and MongoDB inside the clusters. And we do hundreds of deployments during a day across all these environments. Now, these numbers, you need to add some observability. You cannot manage you cannot monitor manually, of course, the state of this number of applications. So you need to invest also in monitoring. We use the standard for the platform, which is Prometheus. It's a metrics collection system, and Grafana visualization platform, to create dashboards like this. So this gives you visibility, for example, on the resource consumption of a particular microservice. This was extracted earlier. So you can see the uptime, you can see how many resources are being used, and it can go to very, very low level to treat different operation, let's say, use cases. So next steps that we want now to invest is DevSecOps. This is basically introducing security inside the infrastructure, because we believe that security, at least for the data that we manage, is really important. So we want to apply techniques like automated platform hardening to add scanners inside Kubernetes, so that when you try to deploy something, it can already tell you that, for example, you are using a deprecated version, or it can identify certain risks. And we want also to use policy as code to define specific policies for users to be able to deploy their applications. Like you cannot have a microservice, for example, that uses more than 2 GB of RAM. You cannot deploy these kind of microservices on this server. Then we want to move to launching dynamic environments for doing approval testing. And for this, we are using currently in the proof of concept that we are building, we are using Helm to deploy the environment, WireMock to mock to provide, let's say, a mock framework to be able to mock certain REST endpoints, and Selenium to run in the cloud Selenium tests. So with this, we are to 2019, to the present, and now we'll close the presentation with some plans for the future and some insights. So now we want to finish the modernization and migrate applications that are currently not running in this infrastructure. So this initiative, we will either decommission completely some systems, so these will not be migrated, or some will be modernized and included into this platform. We want to have a vendor-agnostic multi-cloud deployment, so we want to start looking into a possibility to extend our data center to the cloud. And we want to start thinking about using infrastructure as a service and platform as a service internally to provision resources, but also to external stakeholders that we collaborate with. One of the initiatives that we will try to do is to provide cloud services to EU agencies and IP offices, either infrastructure or directly services, for example, in the context of IP register project, maybe blockchain nodes. And then we work actively with EU agencies to do capacity building and help them with their digital transformation initiatives and cloud endeavors. So some takeaways. It's not easy. So higher efficiency means higher complexity. It's very important to invest in your teams and have everyone on the same page. So you need highly skilled individuals into the specific platforms that you work with. So it is important to invest in training and documentation for new people to be able to understand how the platform is working. We need to build a healthy culture, so everyone needs to be on the same page. Teams need to know where we are going, which is the roadmap, and what exactly is the vision for the future. Most importantly, management. We need to invest in automation and observability, because without this you cannot manage these numbers of resources and this kind of complexity. And all these make a huge enabler in agility and productivity. Imagine now that in the past you needed a couple of weeks in order to in order for operations to be able to provision new machines, new virtual machines to run a proof of concept. Now, at least in the non-production cluster, which is managed by development teams, you can start a new application in minutes. You can try new technologies, and let's say our proof of concepts now defined in code can be launched as many times in as many environments as we want, and we can try different things. And finally, this builds an accessible and standardized platform. What does this mean? That in the future, people will actually be aware of how this platform works. Maybe now we have already seen that there is experience on the market already, but in the future, people will come into an organization that is leveraging this kind of technologies that are standard, and they will be able to understand directly with minimal effort how the systems at least are being deployed and how they can interact and start being productive using these technologies. And with this, I think I close. Thank you very much.
Well, Panos, impressive. You managed.
More or less, no?
Yeah, very good on timing. Really, you speed it up and.
I ran a lot.
Yeah, very good. It was good. So, questions for Panos, please. Comments, observations. We are saying goodbye to our Spanish colleagues. Bye, Ana, Begoña. Have a good trip.
Gracias.
Thanks for coming. Guys, are you sleeping? Come on. No question, no comments? It was so clear, Panos, that...
I have a question.
Okay, good. Thank you.
Have you been able to compare, the return on investment, or the cost of operation versus, now versus what it was before?
I don't have I don't have numbers. We haven't done yet, let's say, study, but we were already managing infrastructure, and infrastructure was already, we had already problems, servers were failing. So operationally, I think that this is included, say, in the same, more or less in the same effort that we had with the previous systems. And don't forget now that we are actually running everything in parallel. So we don't have a good, let's say, measurement at the moment on this cost. However, we can see that the agility that it offers in terms of provisioning new infrastructure actually cuts down from these operational costs that you had in the beginning that were related to the provisioning part. However, maintenance, I would say that at the moment is about the same, and maybe even more because of the effort, the additional effort to tackle the learning curve.
More questions? Panos, perhaps you can explain, for example, because we were talking yesterday about the IP register, and we perform a prototype in blockchain, and one of the things we wanted to do is to be able to create an environment for the prototype, because we are doing some demos. Unfortunately, there was no time for us to give you a demo, but this can happen in the future. So I asked Panos, okay, Panos, how can we do this fast? And could you explain a little bit how long it takes, for example, to create?
Basically, the proof of concept that we have done for the IP register, all the deployment platform is defined in code. It has been configured, for example, that you can configure any number of offices of nodes in the blockchain, and it will just start distributing new infrastructure for the new nodes. This has been done by containerizing the blockchain platform, and on top of this, by let's say deploying new microservices that are offering the services of each office. So having this in code and be able to, by configuration, to deploy new infrastructure, it actually takes about, I think, 2 or 3 minutes to start up a complete environment for the proof of concept from scratch. Of course, later you need half an hour to load all the data, but at least the infrastructure is being deployed. So, for example, now if we want to add the 5th node into the network, we can just do that by configuration. In 1 minute, it starts up and starts synchronizing with the rest of the data that has been shared inside the blockchain.
Thank you. So quite impressive, especially if you need to do something quick, like building an environment. It's quite fast. Any of you already using, for example, Kubernetes? Raise your hand. Any experience that you want to share on that? About complexity or, I don't know, whatever. Please, Graham.
Yeah, so we've rolled it out 6 months ago, roughly. So we're going to talk about the renewal service in a minute, which is running mostly on Kubernetes, or at least half on Kubernetes. So we're rolling more and more onto it, running it on-premise at the moment. We're looking to use Azure Kubernetes service going forward, so we don't have to manage the Kubernetes platform ourselves, because that's an absolute nightmare, as we are rapidly finding out. So that would be my tip to the uninitiated.
Okay, thank you. Then what I'm going to do is I'm going to invite you to move into the speaker area. We should thank Panos, please, for the presentation and the fast delivery.